Speaking up here, Paul Connor, working for the Layer 7 API management group with inside of Broadcom software. I've been in the API space for quite a while. When I first came into it, I was really working primarily around sort of integrating back-end systems and getting the data from them back out to other back-end systems and possibly exposing that out to some web app or some mobile app that you control yourself. From there, I sort of pivoted and went into, I guess, the open APIs sort of space, you know, businesses that run their business on APIs, like the guys from Twilio that are out here, and that kind of business model. Heaps of work around, you know, partner engagements, adoption, you know, hackathons and all that kind of space. More recently, where I've come to is, nothing up there, come to is the space where we kind of intersection of identity security and API security. And I think this is a really interesting space as we're moving, I guess, away from things like SAML in that identity space towards OIDC, and OIDC, you know, being then used to give ID tokens to an access gateway that's then enforcing some kind of controls. I'm just going to flick over and put the slides up so I can at least see them on the screen here. It's unfortunate we don't have anything up there, because a picture does help you keep up with the story a little bit, doesn't it? I'm not sure what happened to the help that was here. Can I just drag it across to there, across to there, and then find that up there, and then look at that screen to press that button there. All right, so back in business, and then the clicker's going to go down. There we go. All right. So then, so that's that intersection between the identity security and the API security. And I think, you know, as I mentioned before, that they have a lot in common. You know, the title of the session here is "Friends Don't Let Friends," but you know, in many ways you could see these friends as being possibly, you know, cousins or siblings. They have a lot of common DNA in place with that OAuth protocol being used for access control, as well as the OWASP top 10. If you look at that, it's riddled with things that are around access control, identification, authentication. So these two really have to work quite closely together in order to provide that secure experience for users trying to access data. So this then is an example of like a user experience going through a typical application. On the top of this, you'll see the identity security aspects, and on the bottom, it's more the API runtime experience. And if you think about the top part of this, you've got a lot of, it's kind of a stop-start experience. You know yourself, if you go to sign on, you get asked for a username and password, and then all of a sudden it maybe prompts you in a different channel for some multi-factor. It could be a push notification to your phone, maybe a YubiKey for biometrics, or maybe some one-time password sent to your email account. And so that experience is, there's lots of gaps and delays in that, and you're kind of used to that because it kind of happens at the front end or maybe once or twice during your session. And other than that, you're looking for a snappier response. So that's the bottom part of this diagram. This is where the API runtime policy comes. This is where you really need to make sure that things are happening in line with that user expectation as they browse across the application, drill down on some data, get more data refreshed. It needs to really be snappy for them. The challenge is, though, at the same time as that snappy response for the user experience, we've got these zero trust initiatives that have been around for quite some time now, but have, I guess, taken a refocus in terms of, you know, all this remote working and moving data to the cloud. So now we have this mandates coming through around, you know, continuous authorization, continuous authentication, and continuous risk evaluation. So you're kind of busy down the bottom here. There's a lot of stuff to do to make sure all that happens, while at the same time providing a great user experience. So potentially those two things could work against each other and provide the worst of both worlds. So let's look a little bit deeper into what's happening down in that runtime API enforcement layer. And I think on the left-hand side of this slide here, the bottom three there of those things that are happening in the runtime policy space are kind of like that integration stuff that I spoke about, that I started off doing mainly. The bottom one there, you'd probably have a lot of debate whether orchestration should be or shouldn't be in there, but it ends up being in there. The top three, though, is more around what we're dealing with predominantly today in terms of this session revocation, checking sessions, and how do you manage that because of these claims-based tokens we're using in order to provide that information. And the next two down from that, these are commonly occurring, but I think they really came to the forefront when we started with these open banking initiatives a couple of years back. And you've got these coarse-grained entitlement checks. In the banking world, it's something around possibly do I have access to accounts A, B, or C, or all of those? And then that fine-grained entitlement check was, well, maybe do I need to see, or to read-write? Can I actually just read the data, or can I update accounts? Or do I possibly have access to the account balances or the account balance in the transaction? So that fine-grained authorization needs to happen in this API runtime as well. Then there's the enforcement point for those policies, and that enforcement point is expanding and growing and proliferating. So you can have the traditional ingress controller, such as like an API gateway. You can be doing that in the endpoint itself. Sometimes for things like that fine-grained control in an open banking situation, maybe the only place that needs to know about that authorization context is the endpoint itself. So maybe there's no need to put that anywhere else. Or you can possibly use things like sidecars or cluster-wide agents that help you provide that service to a range of other services running in an environment. But that enforcement point is not necessarily the same as the decision point. So the decision point you can have for these policies can be on the enforcement point itself, or it can be delegated out to anywhere else in your environment or outside of your environment for that matter. By doing the delegation of that to some other external decision point, the nice thing is that all these enforcement points don't need to know about policy. You don't need to understand it, to interpret it, to enforce it. So your life's easier, the applications you to build are easier, it just delegates that off. And so in many ways you think, well, why wouldn't I do that all the time? And so kind of there's the catch. It just doesn't scale. You can't do this either because of high latency or low latency expectations, or if you've got high scaling requirements, that call out to external place just won't work. So given that we've got that conundrum and we need to get to some point, we need to work out how to deal with that, let's step through some of the aspects of that. Just checking my time there. So the first aspect we need to think about, and this is, it's titled distance to decision, but it's probably more aptly called the time to decision. So this is that latency we had in that UX flow I showed you before. And I described those three options at the bottom there, but you're really thinking about, well, in my particular use case, you know, how much can I sustain in terms of a latency or time between my decisions? You know, and if you've got the luxury of the left-hand side there, then you send it out to some external service. If you don't have that luxury, then you look at these options on the right-hand side here being the enforcement or the sidecar or the cluster-wide property. And so it's a balancing act, and most likely you're going to have to deal with combinations of these. You're not going to be able to get away with just one of these by itself. So then when you're thinking about, you know, where to propagate it to, you also got to think about, well, when should I propagate? You know, you don't always send information close to the enforcement point. And here's this sort of flow diagram gives some of the, I guess, the common scenarios. There'll be other ones you need to come across, but let's just step through these as an example of the thinking you need to go through in the context of a token revocation check. So the first one is, and this is where I think most people start, you just say, well, I've got an access token, I'm just going to tweak the lifetime of that, and I'll just tweak it. If my users are complaining there's too much risk and too much possible hacks happening, I'll just tighten that up and have to refresh the thing more often. And that gets you, by most of the time, it gets you starting quite well. Or alternatively, you may have a situation where you've got a low number of transactions per second. So you think, well, it's only 20, 30 transactions per second. I've got myself kind of a latency expectation that's average. Maybe I can just get away with not just checking every time. I'll send it out to this remote system. It's no scalability issues, so I'm still, happy days and good to go. Or possibly you've got something like think of an e-commerce application where you've got like a shopping cart and you browse a catalogue and you drill down to catalogue items, and these are all API calls happening, and then you add them to the shopping cart, and then you get to checkout. Well, maybe the API calls for the checkout are the high value ones. Maybe they're only 10% of your calls. So maybe you do the local enforcement for those ones only, and for the rest of them you just do distributed. So you're balancing out when and where and how you do this. But at some point, as the flow diagram goes, there will be some use cases that bring you to the point of, okay, yeah, I've got no option. I've got to get it closer. My use case requires getting that information out. So the next thing we'll look at is some of the the things we need to consider in terms of how you propagate that. The first thing is you need a format for that. So every ingress or enforcement point seems to have its own format that it uses internally. So you've got to have some standard format for this, and then a way to ship that out and have it ingested and applied at that enforcement point. You need to be thinking about those different levels of scope. So you may have some global policies that can be shipped up by a distributed service, and you may have some policies that have a local scope and need to be applied at the enforcement point. And you need to combine the two of those. There needs to be propagation at some point. Propagation, like in all things, it needs to be defined as code, lifecycle managed, source controlled, and then shipped out to the runtime environment, and then combined with that runtime environment somehow. So there's components that need to be combined and redeployed. And then the last item there, which is, I guess, if you've done any sort of looking into OPA or Styra, these open policy agent initiatives, there's a lot of great work happening there, and a lot of large companies, the Netflix and the Atlassians of the world, using these types of frameworks to be able to scale and propagate policy out closer to the enforcement point. So if you haven't looked at those and you're interested in this topic, you definitely dig into those when you get some time. So that was sort of bringing us sort of describing sort of the problem, and the key problem being scalability here, and then some of the things we need to manage in terms of when, what, where you manage that policy propagation. The next set of slides here is looking at, so we took that theory and said, okay, theory's great, and theory's easy to talk about. Let's try and create some prototypes around this to actually sort of implement the theory and see how it works. And so the top right of the next 3 slides, you'll see these are public Git repos. And so you can go to the Git repos, access all the collateral we put together. They are built upon using the layer 7 API gateway as the ingress controller, but there's a lot of artifacts around that you could take and use whatever your enforcement point is. So the first one here is around the time check. I've got 10 minutes here. What is the actual time I've got to go? 8 minutes, yeah. So the first one here is looking at, rather than using a poll or push mechanism to propagate the information, using a pub-sub design. So pub-subs, we looked at the work being done by the OpenID Shared Signals and Event Working Group, if you've come across that. They've done a lot of great work taking the security event token sort of envelope and putting in defined sort of payloads into that, combining the CAPE and the risk work. A lot of great stuff been done here by Google and Microsoft in terms of getting their IDPs to be compliant with this. So if you're looking at working into a broader ecosystem, you can go the full path of adopting these sort of protocols. But if you control the identity layer and the API layer in your environment, you can possibly adopt part of this. So the project I worked upon, we took the set format, the drop token format, shoved some CAPE events into it, and just sent them directly across to the enforcement point to get it to work, bypassing the need for that broker function you need in a pub-sub paradigm. So either way, but if you start down this path, you're going to end up being aligned with all the big IDPs that are working in this as well. So something to look at there. The next one, now this is your classic example of government's life cycle and then deployment runtime. So you've got this classic style of going ahead, defining your policy, testing out lower environments, agreeing it's all good to go, pushing it into some Git repo, and then we put together a Kubernetes operator that was looking for commits on that Git repo, and when it saw a commit, it sucks down the new policy, it combines it with the runtime components being the ingress controller, creates a new bundle, deploys that using Kubernetes to seamlessly bring to life the changes in the policy and propagate them. And then the third example is a hybrid. And so the previous 2 examples are kind of like not mutually exclusive. You could do one or both or either or. In this case here, I guess we really wanted to play with OPA a bit more. So that was kind of what drew us down this path. And so we took the previous example of that traditional, take some policy, put it through a source control, push it out to an endpoint and have that enforce. And that policy itself has in it the option to, for certain APIs, it'll deal with it locally. And for certain APIs, it's going to say, well, I've got this global policy I need to apply. I'm going to call that to the OPA agent, which is running locally, bring that into my policy and apply the 2 together on the way through this runtime process. So This kind of setup, I think, is where we're heading more. We just need to get that combination. The OPA stuff that I've worked with, OPA's great at creating these policies for, I guess, the if then else sort of conditional checks and what to do next and returning the values. But there's a lot of things that happen in that runtime API policy I described that it doesn't do. So you're going to kind of need some mix of these two, but definitely offload whatever you can to these OPA agents if you've got the opportunity. Okay, so that's good. So I've got 2 more slides anyway, 5 minutes. So the last one that we said, okay, well, this is great. So we've gone through all this and we've thought about, policy propagation, traditional ways of shipping information from A to B and then combining it and making it accessible, whether it's ingress controllers or cluster caches or whatever it is. Then we thought, well, what if you were to try to look at an approach that said, a lot of applications have been built around microservices. They're event-based these days. So if you had an event-based architecture, can you leverage that event mechanism to somehow do some just-in-time authorization? And so the top right there is the before picture, maybe an e-commerce type application. A new order event triggers 2 microservices. The second of those triggers another event, which in turn ends up delivering the goods or services out. So that's got its own flow through that, and it's been scaled and designed and architected to work in the parameters it needs to. Now you want to add in an authorization check into that. Well, if you could trigger that authorization check off the new order event so that it happens in parallel in its own environment, and provided that it can complete its assessment prior to the fulfill order triggering its event, then you're able to inject this into the flow without affecting the scalability of the original application. So I think that has a lot of opportunity to take this design, but still there's quite a bit of work to go through to make sure that one little thing I said about making sure the authorization check completes before the event triggers the flow through. So that was what I had to cover. I am going to quickly summarise that for you. Well, the title of the session was "Friends Don't Let Friends," but I think friends, would hope friends that would centralise where it makes sense, because it makes your life easier. If you make your life easier, then the application you build will be sustainable and maintainable going forward. So you don't want to over-engineer it to start with, but have in your mind the fact that you're going to have to deal with this for a subset of your use cases and appropriately deal with those. Making sure that you're thinking about multi-clouds, so you're going to have stuff running on-prem for quite a while, or your own sort of infrastructure. There's going to be the need to go to multiple data centers because, I don't know, where I work, the Google, we were Amazon, we're going to Google. The Google bills are shooting up pretty fast, so we need to work out how to balance that out. So make sure you think about that. Do keep centralising design. That's not a bad thing, and OPA and things like that help with managing that and sending it out. Balance that reward and effort when you're looking at engineering ways to propagate. It may not always give you much benefit in terms of the scaling issue you're dealing with, but so make sure you don't do that where you don't need to. And the last one there, certainly look for opportunity to decouple. Don't go for that traditional. It has to be in line so that everything goes through this policy to get to the output. Try and put things in an event-based architecture where you can trigger it out of that sequence and scale that way. So that's a wrap.
Does anyone have any questions for Paul? We've got a couple of minutes for questions.
Anyone use OPA at all? Just hands? Anyone? Yeah. Only a couple. The rest of you have a look at it, And what about CAPE? Who's heard of CAPE or looked at CAPE? No one? Oh, well, you can look at that. It's coming, I tell you, because that zero trust stuff, you must have heard zero trust is coming down your throats from the top level all the time now because of remote working and the likes. You've really got to get that continuous stuff happening, and so the ability to have a session running and then to have a risk context change. Maybe they've gone from a VPN onto a Wi-Fi network or whatever that event is. It changes the profile of the session that was really granted. You've got to be able to feed that back into the session and disrupt or re-authenticate to make sure that you've got secure sessions going on. So, to take away homework stuff, look at those two things for sure. I think you'll find they'll come in handy as you deal with problems coming up. Yep.
Any information on what the cloud identity systems, like let's say Azure Active Directory or Google Identity, whatever, trying to solve that problem if we just stick to one cloud, not the
Can I get you to repeat the question?
Yeah, so the question is, how are the cloud providers trying to help make it, you can use multiple clouds? And there's a session coming up about this, but my thought is that I think Kubernetes is going a long way towards this. You can move workloads, using Helm and the likes, you can use workloads around between, is a common layer between the different cloud vendors. And you've got OpenShift for on-prem. OpenShift's got a bit more complexities, but I think that initiative, whether it's on purpose or not, but the problem with each cloud vendor is they give you all these gateways and bits and pieces, load balancers, and the load balance on AWS, the load balance on GCP is different. It doesn't work the same way, and so it's a nightmare to try and do that. So I think they're trying-ish, but their design is not to make it easier to migrate. Let's be honest. Yeah.
Cool. Thank you, Paul.
All right. Okay. Thanks.